So in this lesson, we're just going to be reviewing some basic geometric properties that you learned in grade 9 for sure, possibly in grade 8, possibly even going all the way back to grade 7. And these geometric properties are going to be important to us when we're solving problems through Unit 10, 11, 12, 13, and 14, 15, which are all about trigonometry. So we're going to talk about things like complementary and supplementary angles, interior and exterior angles in triangles, and angles in parallel lines. So we'll start with complementary angles. We can see some complementary angles over here on the right-hand side, and complementary angles are just angles that add up to 90 degrees. And we know they add to 90 degrees because they gave us this nice little right angle symbol down here in the corner. So if we wanted to find the size of this unknown angle here, we could just do 90 minus 25, which tells us that this angle is 65 degrees. Over on the right, supplementary angles. When you add two supplementary angles together, they form a straight line. You can see the straight line going across here like this. So they have to add up to 180 degrees. So if we were looking to figure out what this angle is right here, we would just do 180 degrees minus the 45 degrees, and we would know that that angle is 135 degrees. And if we have two lines that go across here, at a point like this, we know that angles that are opposite each other in that intersection are equal to each other. So angle A here and angle B here, which are on opposite sides of that intersection, are equal. Similarly, angle C and angle D are also equal to each other because they're on the opposite sides of that intersection. Triangles. You learned last year in grade 9, I'm sure, that the sum of the interior angles in a triangle is 180 degrees. So if I take angle A, angle B, and angle C, and I add them all up, I should get 180 degrees. And that's what I get for this triangle. 50 plus 84 plus 46 is equal to 180. And that's true for any triangle. So the three main types of triangles that we encounter are what are called equilateral triangles, where all three sides are equal. And these little tick marks here, here, and here tell us that those sides are equal. Isosceles triangle that has two equal sides, and a scalene triangle where none of the sides have equal lengths. Now the question I've asked over here on the side is, what about the angles? Well, in an equilateral triangle, all three of the angles are the same size. So we have three equal angles as well as three equal sides. And of course, each of those angles has to be 60 degrees because that 180 degrees has to be split evenly between those three angles. In an isosceles triangle, there are two equal angles, and these are the two angles that are opposite the two equal sides. So this angle here and this angle here are equal to each other. And as you've likely guessed, in a scalene triangle, there are no equal angles. So how do we put this information into practice to solve problems? Well, we could be given a triangle and we could be asked to find the missing angles. So in our first one, we're trying to find angle A. We know that these three angles, A, B, and C, have to add up to 180. So angle A is just going to be 180 minus 36 minus 46. This tells us angle A is going to be 98 degrees. In our second one over here on the right, they only give us one angle. They tell us angle C is 31 degrees. But because this is an isosceles triangle, we know that these two angles that are opposite these equal sides here and here, have to be equal. So this has got to be 31 degrees as well. Then we can figure out that angle A is just going to be 180 minus 31 minus 31 degrees. So angle A has to be 118 degrees. we can use some similar sort of reasoning down here in our third example. We've got an isosceles triangle again because two sides are equal, which means these two opposite angles have to be equal to each other as well. We can figure out what those two angles have to be because those two angles together have to give us the rest of the 180 along with the 68. So if we do 180 minus 68 degrees, we know that those two green angles together have to add up to 112 degrees. Because those two angles are equal, that 112 degrees is split evenly between those two angles, so each of those angles has to be 56 degrees. So we can add that to our diagram, 56 degrees, 56 degrees. Now, if we wanted to find this final angle out here, now that we know that the 56, we know that the 56 and the angle we're trying to find are supplementary angles, so they have to add up to 180 degrees. So 180 degrees minus 56 is going to be 124 degrees. So this angle would be 124 degrees. Two more little questions here involving angles and triangles. On the left here, we've got 55 degrees and 61 degrees inside the triangle. So we know that this angle in here is going to be 180 minus 55 minus 61 degrees. That angle is going to be 64. Once we know that this is 64, we can easily figure out what angle A is. Angle A is going to be 180 because A and 64 add up to 180 because they form the straight line. 180 minus that 64, which is going to be 116 degrees. In the one over here on the right, we are given the 137 degrees, we're given the 93 degrees, but we don't have any of the angles inside the triangle. So probably what we're going to have to do is start figuring out what are these angles inside the triangle. We can start right here. We know that the 137 and that blue angle are going to add up to 180. So if we do 180 minus 137, we get 43. So that's got to be 43 degrees. We can do the same thing for this angle right here. 180 minus 93 degrees is going to give us 87 degrees, which lets us then figure out this angle in here because those three angles inside our triangle have to add up to 180 degrees. So if we do 180 minus 43 minus 93, we're going to end up with 50 degrees. Sorry, minus 87. 180 minus 43 degrees minus 87 degrees is going to give us 50 degrees. So this has to be 50. And then we know that B on the outside and that 50 degrees add up to 180. So B is going to be 180 minus that 50 degrees, 130 degrees. That was the one we were after all along. So sometimes in these questions, it helps to figure out, just to start by figuring out any angles that you can on your diagram and using those to help work your way towards the angle that you want. All right, so if we've got two parallel lines, and in this diagram over here, A and B and C and D are parallel, and they indicate that they're parallel by adding these two little arrowheads here. So if we've got parallel lines, we have three different sort of patterns of angle relationships that we can recognize. The first one are what are called alternate angles. And alternate angles are sometimes referred to as this little Z pattern. Okay? Z pattern or Z pattern. Okay? And alternate angles are equal to each other. So the dots here and here indicate that those two angles are equal to each other. Now we could also have drawn our Z or our Z pattern backwards like this. That would tell us that this angle and this angle are equal to each other. So it's the two angles that are kind of in the corner of that Z pattern that are equal. Corresponding angles are sometimes referred to as the F pattern, because we can draw something that looks kind of like a capital F, right? And in this pattern, the two angles that are under the arms of our F are equal to each other. So those are the corresponding angles, and they are equal to each other. Now, we don't have to draw our F pattern like that. We could draw it backwards. We could draw it upside down. So for instance, I can draw an F like this. That would tell me that these two angles here and here, which are in sort of the same sort of places in my upside down and backwards F, are going to be equal to each other. Our third pattern are what are called co-interior angles. Co-interior angles form what is known as a C pattern. So if I've got angle A and B here, I can draw my C kind of like this. And angles that are co-interior to each other add to 180 degrees. So A plus B in this diagram are 180 degrees. And just like our F pattern and our Z pattern, we could draw our C backwards like this, which would mean that this angle and this angle add up to 180 degrees as well. So let's take a look at these angle properties in action. And in each of these diagrams here, we're asked to find the measure of the unknown angle. So we can kind of get a starting point anywhere we want. In this first one on the left here, we've got this angle of 65 degrees. I might draw my F pattern like this. That means that this angle here and this angle here are the same. So I would know that D is equal to 65 degrees. And once I know that D is 65 degrees, I know that angle C in here and D have to add up to 180. So C is going to be 180 degrees minus 65. C is going to be 115 degrees. In our next pattern, I might jump in at angle B here because I can see that the 125 degrees and angle B form a straight line. So B is going to equal 180 minus that 125. So angle B has to be 35 degrees, 55 degrees. So it helps sometimes to add that onto my diagram. There we go, 55 degrees. Now I could see that I might draw a Z pattern like this, which tells me that this angle and this angle are equal to each other. So angle A is going to be 125 degrees. So I could add that to my diagram as well. And now I can see that A and C are opposite angles at that intersection. So C is also going to be 125 degrees. Over here on the far right, I've got two parallel lines there and there. So I can draw a backwards, a C pattern like this, which tells me that angle X is going to be 180 degrees minus 50, 130 degrees. Okay. Or I could draw a different C pattern that is backwards. That tells me that angle Y and the 130 have to add up to 180 degrees. So angle Y is going to be 50 degrees. Our last two down here, I've got angle D, E, and F that I'm trying to find. I would probably start maybe with angle D here. I can see that we have a Z pattern in here, which tells me that this angle and this angle are going to be the same. So D is going to be 75 degrees. Add that to the diagram. Then I can see that D, E, and that 70 degrees all go together to form a straight line. So E has to be 180 degrees minus 75 minus 70 degrees. So angle E has to be 35 degrees. We can add that to our diagram, 35 degrees. Well, now, angle E and F, let's change colors instead. E and F form a little Z pattern in here. So from that Z pattern, F has to be 35 degrees as well. Our last one over here on the right side, we've got K, M, and N. We could start maybe with angle K. We've got a little bit of a Z pattern right here because this line and this line are parallel. So that tells me right away that K is going to equal 85 degrees. M is opposite to that 40 degrees, so M is going to be 40 degrees. And once we know what M is, we can draw an F pattern, which is kind of on its side. That tells me that angle M and angle N are going to be equal, so N is 40 degrees as well.